Hello everyone. Good afternoon. Very good afternoon to all of you. How are you all? Good afternoon, Naveen Kumar. Good afternoon, Tanuja. Fine. Have you all revised the thermodynamics lesson? I said that we are going to discuss the uh, previous year's questions of thermodynamics lessons today, right? So did you guys revise the concepts and the formulas and the theory part of the thermodynamics lesson? How many of you have revised? Just give me your answer in the chat box. So before proceeding further, I would like to launch a poll, okay, to check the class status. So let me know if I'm visible and audible. Yes? Okay. Fine. Let's move ahead. So I hope all of you have revised the formulas. Yes or no? Yes or no? How many of you have revised? Not even a single student has gone through the formulas which we have discussed in the class. That's really unfair, no? Okay. So now we'll proceed with the questions. Are you all ready? Are you all having your notebook and the class notes and the pen with you? Shall we start? Just give me a thumbs up or type yes in the chat box so that I can proceed with the question. Yes. So keep the notebook, keep the pen, and have your class notebook with you. Okay. So for referring the formulas, I think many of you have not revised. I think so. Please try to revise. Okay. For today, you can go through your notebook and you can tell me the formula. But at least from tomorrow onwards, try to memorize all the things. Okay. Today itself, try to go and study all the formulas. Okay. So now we will go to the first question of today's session. So here is a question. Under isothermal condition, a gas at 300 Kelvin expands from 0.1 liter to 0.25 liter against a constant external pressure of 2 bar. The work done by the gases. And 1 bar value is given in terms of joules. Okay. 1 bar value is given in terms of joules also. So, how to proceed with this question? Sorry, I could not turn on my video right now. Okay. So, how to proceed with this question? How to find out the work done? Any idea which formula we have to use here? So, which formula we have to use here? We have to find out the work done by the gas, right? So, we are given with the temperature. Okay, so temperature value is given and volume is given. So the initial volume is 0.1 liter and the final volume is 0.25 liter. Okay, against a constant external pressure. Constant external pressure of 2 bar. So this is the value for P external. Okay. And using these values, we have to find out the work done. Okay. Now for isothermal condition, the formula to find out the work done is equal to minus P external V2 minus V1. So this is the work done formula, right? So I have given you 3 formulas to find out the work done. Okay, and for this question, we have to use this. This is the work done formula for irreversible process. How do we know that the process is irreversible? Because it is acting against a constant external pressure. If the external pressure is constant, then the process cannot be reversed back, right? So we have a system and we are applying pressure to the system, and this is the external pressure. And if this pressure is constant, then the work cannot be done by this gas, right? So it cannot be reverted back. So it is irreversible process. So this is the formula to find out the work done for irreversible process. Now substitute all the values. It is equal to minus the external pressure is 2 bar and the V2 value is 0.25 and the V1 value is 0.1 liter. And so here the pressure is given in terms of bar, right? So let me put that also, which will be equal to minus 2, 0.25 minus 0.1. What is the value? It is 0.15, right? It is 0.15. Yeah, very good, Tanuja. So let's arrive with your answer, okay? So it is 0.15 bar liter and yeah. Very good, Roshan. So now 2 into 0.15 is equal to minus 0.30 bar liter, okay? Now we are getting the answer for work done in terms of bar liter. But we are asked to find out in terms of joules because in all the options we have joules, right? So how to convert? So 1 liter bar is equal to 100 joule. So what we need to do? We have to multiply this number with 100. Okay. So that will give us the value in terms of joules. So it is minus 30 joule. Okay. It is minus 30 joule. So option C is the correct answer for this question. Is it clear? Can you all able to understand this question? Can you all able to understand this question? Do you have any doubts to ask from this? So are you all getting option C as the correct answer, students? If you want to note down this, you can note it down. Shall we go ahead with the next question? Shall we go ahead with the next question? Say yes or no, students. Shall we go ahead with the next question? Yes. All right. Good. So now we'll go for question number 2. This question is also similar to the previous question. Okay. So I have a new student today, I think, whose name is Abhinash Chetri. Okay. I haven't seen Abhinash before in our class. Okay, fine. Expand in a well-insulated container against a constant external pressure of 2.5 atm. Okay. So what is given? The constant external pressure is given as 2.5 atm. So this is the P external value. From an initial volume is 2.5 liter V1 to a final volume is 4.50 liter. The change in internal energy. We have to find out the delta U for this question. How to find out? How will you find out the change in internal energy for any type of question? What is the formula we have to find out the internal energy? Can anyone tell me? What is the formula to find out the change in internal energy? Delta U is equal to Q plus W. What is this? This is the formula we get from the first law of thermodynamics. Okay. So this is the formula we have studied in the first law of thermodynamics. Very good, Rakshita. It is Q plus W. Now, from this only we have to find out the value of delta U. So now we can find out the work done, but how will we find out the Q? Q is nothing but the heat exchange. Go to the question and read it once again. So the question says that the container is a well insulated container. So what is meant by insulated container? Insulated means that exchange between the system and surrounding. Okay. Insulated means it will not conduct the heat. So it will be zero. It will be zero. Okay. So Q goes to 0. So delta U is equal to W. Delta U is equal to W. So if you find out the W value, then that will be equal to delta U, which will be the answer for this question. So now what is the formula to find out the work done? The same formula, minus P external. Okay, because the external pressure is constant. So P external V2 minus V1. So substitute all the values and find out the answer. External pressure value is 2.5 atm and V2 is 4.5 liter and V1 is 2.5 liter. Now if we subtract this, what we will get? We will get 2, right? And 2 into 2.5 is equal to 5 liter minus 5 liter atmospheric pressure. And now we have the values. So I have given you the answer, right, as option B. So let's try to arrive at that option B. So in all the cases, the answer is given in terms of joules. So we have to convert this liter atmosphere to joule. Okay, how to convert? So to convert 1 liter atmospheric pressure to joule, you have to multiply by the number 101.325. This is the conversion factor. Okay, 101.325 joule is the conversion factor. So multiply with that number, minus 5 into 101.325 joule. And if you multiply this, you will get minus 506.625 joule. Okay, but the nearest approximate value is 505, minus 505. So that's why option B is the correct answer for this question. Okay. So in some question, they will give you the conversion factor. In the last question we had no, but here in this question, they did not give. So we have to memorize. We have to memorize all these conversion factors. If you do not know this before, you can note down these conversion factors in your notebook now. Okay. So is this question clear? Any doubt from this? Do you have any doubt from this? Shall we go ahead with the next question, students? What about others? Only Rakshita is answering. Okay, it is clear. Fine. So now let's go ahead with the third question. Okay. Here is the third question. The total number of intensive properties from the following is volume, molar heat capacity, molarity, E0 cell, Gibbs free energy change, molar mass and mole. So this is a JEE question and that's why we don't have options here because in JEE for 10 questions we won't be having the options, right? So it is a numerical based question in which we have to give in numbers. Okay, so that's why this question doesn't have any option. So tell me how many intensive properties are there here in this list? What about the first one? Volume, is it intensive or extensive? I already told you between intensive and extensive property, right? Intensive property means the property will not change on changing the quantity. Okay, so those are called as intensive. So volume is an extensive property. Volume is an extensive property. So it will not come in the list. What about molar heat capacity? Intensive or extensive heat capacity? Under heat capacity topic, we have discussed this now. Molar heat capacity is an intensive property. Very good, Manish. It is an intensive property. Yes. What about molarity? Molarity is also intensive. Okay. It is also intensive because it value doesn't change on changing the size of the system. Okay. E naught cell. E naught cell is also an intensive property. Gibbs free energy change. Gibbs free energy. Is it intensive or extensive? Yesterday only we have discussed, no? Gibbs free energy. It is extensive. Yeah, so it will not come in the list. Very good. What about molar mass? What about molar mass? It is mass, right? Obviously, it is an extensive property. It is molar mass. So it is an extensive property. So it will also not come. What about the mole? Mole. Actually, molar mass, listen. Mass is the extensive property. Molar mass is an intensive property. Okay. Mass is extensive. Sorry. Molar mass is an intensive property. Okay. And mole is actually number of moles, right? It is an extensive property. It depends on the mass. If the mass changes, number of moles also changes. Okay. So now there are only four intensive properties given in the list. So the answer is 4. The total number of intensive property from the following is 4. Okay. Clear? So just take down this list. You can also write this in a tabular form. You can write intensive, extensive in 2 columns, and under extensive, you write volume, Gibbs free energy and mole, and under intensive column, you can write the other 4. Okay. Is it clear? Shall we go for the next question? Shall we go for the next question? Okay. Okay. 1 mole of an ideal gas is allowed to expand reversibly and adiabatically from a temperature of 27 degrees Celsius. The work done kilojoule per mole. The final temperature of the gases. How to find out? CV value is given. So what is given in the question? We have the number of moles. We have the number of moles as 1. And it is a reversible adiabatic process. And the temperature is given as 27 degrees Celsius. But we have to find the answer in terms of Kelvin. Okay, the temperature should be written in terms of Kelvin. So we have to convert the Celsius to Kelvin. So it will be 27 plus 273, which will be equal to 300 Kelvin. 300. And the work is done by the gas, right? So because gas is allowed to expand. Expand means we have a container. We have increase and the system will expand. So by the gas, the work is done by the gas. So if the work is done by the gas, per mole, 10 power 3. So it will be equal to minus 3000 joule per mole. Okay. So we have the double, we have the T value. Students, am I audible now? Can you able to hear me? Hello, students? Yes. Shall I go ahead? Yeah. So value, we have the temperature and now we have to find out the final temperature. So use this formula. W, we know U is equal to Q plus W, right? And since the process is adiabatic, again the Q is going to be 0. So delta U is equal to W. Okay. So what is delta U? We know we have one more formula to find out the delta U. It is NCV delta T. NCV delta T, which is going to be equal to W. Okay. So now from this you can find out the answer. W value is given, which is minus 3000 joule per mole, and number of moles, N value is also given as 1, and CV value is also given as 20 joule per mole, and temperature delta T. What is delta T? It is T2 minus T1, right? So initial temperature is given here, T1 is given here. We are asked to find out the final temperature. We have to find out the T2 value. So here in place of delta T, I have to substitute T2 minus T1, which is 300 Kelvin. Okay. So now if you solve this, you will get a final temperature value as, okay, can anyone try? Can anyone try the answer for this question? Let me know if you have got the value of T2. So please do the multiplication and division process and let me know the answer. What is the value of T2? Do the multiplication and division. Very good, Roshan. So the T2 value is coming out to be 150 Kelvin. Have you done this question before? No. Okay. Very good. Tanuja, just look into your mathematical part over there. Others are getting 150. Good. Good. So you all of you must get 150. 150 Kelvin is the answer. So that 150 Kelvin. Okay. So from these questions, we are learning how to approach a question. Okay. So first of all, if some numerical type of question like this is given to you, no problem, Tanuja. No problem, my dear. It is 150. You're getting now? Okay, okay. That's great. Yeah. So if you're getting numerical questions like this, you need to first write down the given values. Okay. Now, after writing down the values which is given in the question, you have to think of the formula which has to be applied for that question. This is step number 2. Okay. First of all, write the given values. And secondly, think of the formula which we have studied to approach that question. Okay. Because you know, from the given values, you can think of the formula. Okay. And if you may get one or two formula in your mind. Like for delta U, we have two formulas, right? One is Q plus W and the other one is NCV delta T. So these are the two values which are used to find out delta U. So from that you can find out the corresponding answer. Got it? So only by practice you can get the good confidence. If you practice more number of questions for physical chemistry lessons, you can get good marks in your competitive exams. Okay, without practice, if you just simply learn the formula and if you just simply concentrate on the theory part alone, then it will not help you. Okay, 50% problem solving, 50% memory. Okay, memorization. So these two are important. Got it? Shall I go for the next question? Are you all ready? Shall I go ahead with the next question? Okay. Here is the question. When 2 liter of ideal gas expands isothermally into vacuum to a total volume of 6 liter, the change in internal energy is. This question is very easy JEE mains question it is. When 2 liter of ideal gas expands isothermally into vacuum to a total volume of 6 liter, the change in internal energy is. What is change in internal energy? Delta U. Delta U we have to find out. Again, there are only two formulas, right? You have to use the second formula. Delta U is equal to NCV delta T. Do you know why I have chosen this formula? Do you know why I have chosen this formula instead of Q plus W formula? Can anyone find out the reason for why I have chosen this formula instead of the first? Yes or no? We know the n value. But where is the n value? Where is the n value? We don't know the n value, right? Rakshita, we don't know the value of n, no? Where it is given? We just have only the volume, right? Very good. One of the student has given me the correct answer, but I don't know who is that. The person behind JNB ID. May I know your name? The person who is sitting behind the ID JNV. Okay, okay. Ebor. I don't know whether I'm pronouncing your name properly or not. Ebor or Ebor. Okay, my dear. You are correct. It is isothermal, and one more also have given me. Yeah, Mahalakshmi is also giving me the correct answer. Yes, very good students. Listen, the question they are saying that the process is isothermal. Isothermal means the temperature is constant. If the temperature is constant, then the change in temperature will be equal to 0, right? For isothermal process, delta T will be 0. So delta T will be 0 for this process. So 0 into anything will also be 0. So delta U is equal to 0. Change in internal energy is 0 joule. Okay. So you don't have to think of the volume. Okay. The initial volume, final volume and the other things. You just look into the word isothermal and substitute accordingly and get the answer for delta U. That's it. Very easy, right? Is it confusing for anyone? Shall we go for the next question? Shall we go for the next question? It's very easy question, no? Yeah. So let me go ahead with the next question. Among the following, the number of state variables is. This is again an easy question. So find out the answer first. We have studied two functions, right? State function and path function. State function, state variables, both are same only. Okay. So find out, there are four terms given to us: internal energy, volume, heat and enthalpy. How many are state function? Rakshita is saying 2. Naveen Kumar is saying 3. Which is the correct answer? 2 or 3? What about others? What about others? What is your answer? What about others' answer? Manish is saying 4. Oh, Manish, you are saying that all the 4 are state variables. But 4 is unfortunately not the correct answer. Roshan is going for 3. Okay. So let us discuss. So while teaching in the class itself, I told that only two functions are path functions, right? One is heat and the other one is work. Do you guys remember? Q and W. Except these two, all others will fall under state functions. I told you guys this statement, right? Only except Q and work, all others are state function. So in the given list, we don't have work, but we have Q. So Q is the only path function and the others are the state functions. So the answer is 3. The answer is 3. Are you all getting my point? Can you all able to recollect the concepts we have studied in the class? Except heat and work, all others are state functions. Okay? Shall we go ahead with the next? Shall we go ahead with the next question? Yes. Good. The molar heat capacity for an ideal gas at constant pressure is 20.785 joule per Kelvin per mole. Molar heat capacity. So what is meant by molar heat capacity at constant pressure? It is nothing but Cp, right? Molar heat capacity at constant pressure means it is Cp. Cp value is given. The change in internal energy is also given. So this is delta U. Change in internal energy value is also given as 5000 joule. Upon heating it from 300 Kelvin to 500 Kelvin. So what it is? 300 Kelvin to 500 Kelvin. The change in temperature. Okay. So final is 500 and the initial is 300. So delta T is equal to T2 minus T1. So it will be equal to 500 minus 300. So which is equal to 200 Kelvin. Okay, 500 minus 300 is 200 Kelvin. So delta T is 200 Kelvin. The number of moles of the gas at constant volume is number of moles. N value we have to find out. So how to find out the value of N? Can you guys try for this? So is Roshan getting the answer 1? What about others? What about others? So listen, we know that delta U is equal to NCV delta T, right? So this is the number of moles. So what is NCV? NCV is equal to delta T, which is equal to 5000 divided by delta T is 200, which will be equal to 25. Okay, so this is NCV value. From this, CV is equal to 25 divided by N. Okay, so this is the value of CV, and also we have the value of CP. So we know that CP minus CV is equal to R. So here Cp value is 20.785 and Cv value is 25 divided by N, which is 8.314. So from this, you can get the value of N. Okay. N is equal to 25 divided by 20.785, 8.314. If you solve this, you will get the answer as 2. So the number of moles is equal to 2. Okay. Number of moles is equal to 2. Okay. So the nearest integer will be 2. So this is little bit lengthy and kind of tricky question, but try to learn and understand how to approach this. If you get any other question similar to this, you can approach in the same way I have done here. Okay. So any doubt from this question for anyone? You have any doubt from this question? You have any doubt from this question? Are you all getting this? Mhm. Rakshita, 1.202 is actually wrong. Okay, you will get 2.0048. Approximate value is 2. Okay, 1.2 is actually wrong. You should not get 1.2. If you solve this, 25 divided by 20.785 minus 8.314, you will not get 1.2, you will get 2.0048. Is it okay, my dear? Yeah. Yes, Abhinash, your answer is correct. Rakshita made some mistakes in the multiplication division part. So just look into this and find out where you have made a mistake and do the calculations again. You will get the correct answer. Okay. Abhinash answer. Yeah. Shall we go for the next question? Shall we go for the next question? Shall we go for the next question? Yeah, Rakshita, you have substituted the value of Cp in place of Cv. Can you identify your mistake? You have substituted the value of Cp in place of Cv. Okay, so that is wrong, no? I can able to see your screenshot. In that you have substituted Cp value, right? Are you getting? Are you getting my point? Can you able to understand the mistake which you have made? Yeah. So Cp and Cv are different, no? So you cannot substitute that. You will get 2.0048 if you go in this manner. Fine. So now let's go ahead with the next question. For the reaction H2F2 giving H2 plus F2, delta U is given at 27 degrees Celsius. The enthalpy change for the above reaction is minus dash kilojoule per mole. R value is also given. So how to do this question? It is very, very easy. Let me see who is. Which formula we have to use to solve this question? The enthalpy change. Enthalpy change means delta H. How to find out the delta H from the given values? Delta U is given, delta H is given, R is given, T is given. All of you please think of the formula that has to be applied here. What is the formula we have to use here? Let me see who is going to give me the correct answer. Even a single student has got the, oh my God. But it is delta H and delta U. Okay, your answer is correct. Delta H is equal to delta U plus delta NGRT. Okay, so this is the formula. Delta U is given as minus 59.6 kilojoule per mole. We have to convert that into the other term, right? But we don't have to convert because in the question they are asking the answer in terms of kilojoule only. So just write this as it is 59.6 plus delta Ng. What is delta Ng? Delta Ng is equal to number of gaseous product minus number of moles of gaseous reactant. Okay. So how many gaseous products we have? 1H, 1 plus 1 is 2. And how many gaseous reactant we have? Only 1 mole. So it is 2 minus 1, which is going to be equal to 1. So in place of delta Ng, you substitute 1.314. But R is given in terms of joule into kilojoule. So to convert this, you have to divide this by 1000. Okay. Or multiply by 10 power minus 3. Both are same only. Okay. So that will give you the answer in terms of kilojoule per. And what else we have? We have T. We have the T value, but it should be written in terms of Kelvin. But here it is given in terms of Celsius. So convert this to Kelvin. 27 plus 273. That will give you 300 Kelvin. So substitute the value 300 here and do the calculations. So 0, 0 will get cancelled with each other. And if you add and divide all the things, you will get the delta H value as minus 57.10 kilojoule per mole. Minus 57.10 kilojoule per mole as the final answer. So all of you please check whether you are getting this answer or not. All of you please check whether you are getting this answer or not. Are you all getting this answer, students? 4 into 3 divided by 10 plus or minus 59.6. Are you all getting this answer? Okay, Manish is also getting. So now we'll go for the next question. So far we have discussed the questions from the thermodynamics. So now let us go for some questions from thermochemistry. Okay. So the first question from thermochemistry is, consider the following reaction 2H2 plus O2 giving 2H2. Delta HR naught for the reaction is given as minus 483.64 kilojoule. What is the enthalpy change for decomposition 1 mole of water? So what we are asked to find out? The delta H, the change in enthalpy for decomposition of 1 mole of water. We have the reaction for the formation of 2 moles of. Find out the enthalpy change for decomposition of 1 mole. So this is formation. We have to find out for decomposition. We have to find out for decomposition. So what I have to do first, I have to reverse the reaction first of all. Okay, so all of you please revert back this reaction. So if I reverse this reaction, I will get 2 moles of H2O giving 2H2 plus O2. Okay. Since I have reversed this equation, what I have to do? I have to change this symbol from minus to plus. So for this reaction, delta H will be equal to plus 483.64. Okay. We have to do, this is called as decomposition. One molecule, one reactant breaking down into 2 or 3 is called as decomposition. But we have to find out the decomposition for 1 mole of the number 2. So if you divide it by 2, you will get H2O giving. Divided this equation by 2, I have to divide this 0.64 divided by 2. It will be equal to plus 241.82 kilojoule. Okay. Correct answer. So many of you have got answer. Okay, I hope all of you can able to follow the steps which I am saying. Am I right? All of you can able to. Yes. Now I'll go for the next question. R 2, 3, 10 and 6 delta G naught for the reaction is, and R value is also given. Again, it is an easy question. We have to use the delta G formula. Delta G is equal to minus 2.303 into RT log of. So this is the last formula of this lesson we have discussed. Right? So what is this KEQ? This is equilibrium constant. So how to write the equilibrium constant? It is the product of product concentration. It is the product of products concentration. The products are C and D. So you need to multiply the product concentration divided by the reactants concentration, A and B. Okay. So in place of KEQ, we can substitute the concentration value, and all the equilibrium concentration value for A, B, C and D are given here in the question. Okay, you can substitute directly. So delta G is equal to minus 2.303 into R. R is 2 calorie per mole, and the temperature. Temperature is also given in the question. 300 Kelvin into log of KEQ. So in place of C, we have to substitute 10, and for D, it is 6. For A, it is 2, and the equilibrium concentration for B is 3. Okay. So here, if I cancel this, I will get 2. 2 gets cancelled. Remaining, we have only log 10 here. Log U is equal to 1. Log 10 is 1. Okay. So we are left with 2.303 into 600. 2 into 300 is 6. Like these two, I will get one answer, right? So What is 2.303 into 600? What is 2.303 into 600? Can you find out the value of 2.303 into 600? Which option is correct? Are you all getting option B as the correct answer? Okay, very good. So it is minus 1381.80 calorie. Okay, very good. Option B is the correct answer. So we'll proceed with the next question. For reversible expansion of an ideal gas under isothermal condition, the correct option is for reversible expansion of an under isothermal condition, the correct option is. Which is the correct option for irreversible expansion of an ideal gas under isothermal condition? Isothermal means delta T is equal to 0, right? And we know that delta U is equal to NCV delta T. And here if delta T goes to 0, delta U is also 0. 0 into anything is 0. So delta U is 0 is given in option B and D. So either one of these should be the correct. Delta S. How to find out the delta S using the statement? So statement says that it is irreversible expansion. If it is process, okay, irreversible process is always spontaneous. For all spontaneous, the delta S will be greater than 0. Okay, entropy of the universe will be greater than 0. Okay, it is not equal to 0, it is greater than 0. So option D is the correct answer. Option D is the correct answer. Is it clear for all of you? For irreversible expansion of an ideal gas, for irreversible, process is spontaneous. For spontaneous process, delta S is greater than 0. Got it? Shall I go for the next question? Shall I go for the next question? Okay. So here is the next question. Hydrolysis of sucrose is given in the following reaction. If the equilibrium constant is 2 into 10 to the power 13 at 8, value of delta G naught. So what is given in the option? So we have, it is not IN, it is LN. Okay. Logarithmic function, LN. This question is very, very easy. You don't have to do any calculations. Just you have to find out the answer by substituting the values in the formula. But which formula you will use to find out the value of delta G? Delta G R naught is equal to minus RTLN KEQ. Right? So in terms of LN, we won't use 2.303. So this is the formula. Substitute all the value. R value is minus 8.314 and the T value is is 300. It is 300 Kelvin and Ln of KEQ. KEQ is given as 2 into 10 to the power option D. It is given in option D. Option D is the correct answer. Okay. So shall I go ahead? 1, you guys have to get ready for your next class. We can close up the today's session. And before going to the next class, you give your feedback in the poll which I have launched, and then go for the next class. Okay. Thank you so much for listening to today's lecture. So here we are closing this thermodynamics chapter, and in the next session we can start with the new lesson. Okay. If you are getting any doubts from this thermodynamics lesson after revising, you can feel free to ask me. I'm here to clear all your doubts. All right. So thank you so much for attending the today's class. All of you give your feedback and go.